Well, good evening, everybody, and welcome to our Thursday night presentation. I'm Bill Haas with NACAT, and it's my pleasure to introduce tonight's presenter, Curt Ward from Joliet Junior College and an author for Pearson. Curt, thanks for giving us your time this evening.
Glad to do it. Good evening, everybody, and I offer my welcome as well. Our presentation this evening, hybrid and electric vehicles for gasoline engine instructors. I think I can provide you with some information tonight that might make it easier for you, or perhaps make you more comfortable adding this topic to your program if you haven't done so already. Most of you know me. I teach at Joliet Junior College. I do some writing for Pearson. I'm ASE Master Certified, and I've been doing this for a couple of days. I don't claim to be an expert, but I'm good at listening to a lot of really smart people and taking notes and going from there. So anyway, tonight, some of the things that I want to talk about. And by the way, if you have questions, put them in the chat box. Bill will keep an eye on that for us this evening, and about halfway through, I'll stop and we'll answer the questions at that point. And then at the end, we'll get the balance of the questions. All right. So right away, I want to talk about why we add hybrid and electric vehicles to our curriculum. I also want to talk about high voltage safety, something that I call maintenance and care of hybrid and electric vehicles. This is something you can teach all your students. Talk a little bit about special tools, talk about some system specific information, and I've got some case studies scattered through here that I think are designed to make you more comfortable with this topic, not terrorize you with it. So as we get started, I just want to talk for just a moment about what we're experiencing with COVID, because obviously our classrooms look very different today. You may or may not be seeing your students on a regular basis. I'm blessed to see mine at least in a hybrid format. But even before COVID, we were looking to figure out how we can improve or reimagine our automotive classrooms. And there was a lot of questions that were asked. What do the students want to do? What do budgets allow, etc. And I think as we talk about this topic tonight, hybrid and electric vehicles, I think it's really important. Obviously, we have to meet our requirements today. We've got to be safe. We've got to follow all the rules. But at the same time, we got to anticipate the future. We've got to talk about where is our industry going. And I think it's pretty clear right now that this topic, these cars, are going to be a part of what we see going forward. And perhaps as we're making changes for COVID, we can make changes that last beyond that. And so this may be one of the greatest opportunities that we've had in a long time to make significant changes, particularly as it relates to our curriculum. So why teach hybrid and electric vehicles? The reality is it's one of the fastest growing segments in the industry today. No great surprise when you look at the success of vehicles like the Chevrolet Bolt, the different models of Tesla. The market share is growing every single year. In major marketplaces like Chicago, where I'm at, growing faster than, say, rural America, but it's coming. The other thing to remember is what I call mild or micro hybrids, or some of the start-stop systems out there, or stop-start. They're almost commonplace, even in some basic models. And so this is a topic that, if we incorporate it into our curriculum, our students are going to earn more money when they finish the program. When they go out into the job place, they're going to be in greater demand. The reality is these hybrid and electric vehicles, many of them are out of warranty, many more coming out of warranty every year. And so this is a major player in terms of the aftermarket repair business. So let me start with a case study. This happened to be a vehicle that came through our shop our live shop at Joliet Junior College. So I'm working on this vehicle with my students. It's a 2010 Honda Insight with the 1.3 liter hybrid, relatively common vehicle. Customers concerned with the vehicle was towed in, battery wouldn't stay charged, and this is both the high voltage battery and the 12-volt battery. And typical of most instances, they'd gone down to the local auto parts store, put in a 12-volt battery, and that didn't change anything. They did note that the IMA and the check engine light were both on. So I said, sure, we'll take a look at it. So to walk you through the process, visual inspection step 1, yep, check engine light's on. And yes, we got an IMA light, and yeah, we didn't have enough battery to drive it into the shop. We had to push it in. Okay, so check engine light. Let's start with the easy stuff. Let's plug in a scan tool and let's read codes. All right, any of us would do that. Well, here's what we get. Power not detected at the vehicle adapter connector. Can't establish communications without power. All right, well, we've all seen this before. We make sure we got good connections, and then we start looking for that cigarette lighter fuse or whatever the circuit is that provides that 5 amps to pin 16 at the data link connector. So do our due diligence, we get out the wiring diagrams, we go through, and lo and behold, the fuse that powers the DLC is good. Okay, so now we're going to get the test light. Guess what? No power on either side of the fuse. Okay, so now we know why the scan tool won't power on. And I'm thinking, well, great, I'm going to have to fix this problem before I can even begin to address the next. So I go back to the wiring diagrams and I'm looking some more, and I notice, wow, this same fuse powers up the cargo area light, the ceiling light, the MCM, which is your motor control module, and oh, by the way, the map lights if it's equipped. So I go back to the car, open the door, I look up, and lo and behold, the ceiling lights don't illuminate either. All right, so obviously this isn't a problem unique to the data link connector, and obviously if the motor control module is not getting power on the 12-volt side, there's no way we can charge the battery. So very carefully, we run fused battery power from the battery and carefully back probe pin 16 of the DLC. So we're going to carefully back feed voltage to that point. Lo and behold, scan tool communicates, dome light comes on, and I'm thinking, we've charged the 12-volt battery, vehicle starts, IMI light is off, you go out to under the hood, and lo and behold, the battery is charging at, the 12-volt battery is charging at 14.3. So now it's time to figure out why we don't have power at that pin for the fuse. Long story short, we go through and we do the diagnosis and we determine that the power is coming into the fuse box, but not out on that circuit, and we need a fuse box. The good news is it's a part that Honda services. A day or two later, it was in. We disconnect the battery. We remove the fuse block, and thank goodness, even though all the connectors are green, they all had different pin configurations, would only fit in one spot. So it wasn't a horrible repair. There's our replacement fuse block. It probably took more time to transfer relays from the old one to the new one than it did to install it, quite honestly. This was a smart fuse box. So after we replaced it, we had to relearn the keys, which required us to call down the street to the Honda dealer where we have a friend and get the required code so we can program the keys back in, which obviously takes a compatible scan tool, but that SnapOn scan tool that you saw in the picture worked just fine. And lo and behold, all the systems now work as designed. All right. So lessons learned. Not all high voltage problems are in the high voltage system. And in fact, we never touched the high voltage system the entire repair. The reality is everything we did to make this repair, we learned in electrical fundamentals, or electrical 1 as we call it at our college. So lo and behold, we've fixed a hybrid. And what's interesting is when this faculty member called around and said, hey, here's what I got, and was looking for specifically independent garages who were interested in working on it. Oh, we don't work on those. Those are hybrids. That's high voltage. We never touched it. Anyway, so inquiring minds want to know, well, we took apart the fuse block, and right there on the F11 circuit, we found the open circuit. Unfortunately, once you cut the fuse block open, there's not much saving it, but it was interesting to see exactly what was wrong. So where do we begin? So I've decided I want to teach hybrid and electric to my students. Teach service information. The processes that are laid out for hybrid and electric vehicles are very descriptive, very accurate, and in my opinion, easy to follow and are absolutely a must. But part of that is having a diagnostic process to follow. As part of my advanced course, I teach something called logical diagnostics. And really it's a matter of making decisions based on the results, not bypassing, not guessing, not looking for silver bullets, but following the process. And then the other thing that I've learned in this process is when you think you've taught enough basic electrical, teach more basic electrical. And we'll talk about what other topics to include. But as we get into hybrid and electric, clearly there's some topics that we don't cover enough in our first 2 electrical courses. All right, so what do I teach with? The 4 vehicles that you see here are my training fleet for this particular class. And the first vehicle is a first generation Nissan Leaf. It's a 2011. The second vehicle is a Honda with stop-start, so it's a mild hybrid. The third vehicle is it's an 08 or an 09 Prius, so it's the second generation Prius. And the last vehicle is actually a first generation Mercury Mariner hybrid, or what most of us know as a Ford Escape hybrid. These 4 vehicles were all donated to the program. No, people didn't just fall off out of the trees and say, here, how would you like? It took a little bit of work to go get them, but these are ideal. These vehicles have everything you need to cover the key topics. They are very, what I call teacher and student friendly. You can get to the stuff, you can make the connections. You can drop the battery in and out of the Leaf without a lot of problems because it doesn't have any external heating or cooling systems. It's all internal. Just as an example. So as you start thinking about, hey, this is something I want to do, obviously electric vehicle is nice. We'll talk more about that here in a minute. But I have something with stop start. The Mariner is an early hybrid, so it actually has a conventional belt driven air conditioning compressor. So when the AC is on, so is the engine. And obviously the Prius is some technology that's been around a long time, tried and true, and is a great piece for students to work on. In addition to the cars, make friends in the area with the people who work on these vehicles. Independent garages, the local Toyota dealer, the local Nissan dealer. Make friends with the service manager. Explain to them that no matter what it is, if it's a hybrid component off of one of these vehicles, they are not to throw it away when it comes off the car. They're to call you and you're going to go get it. I have quite a collection of pieces that they would have just thrown in the trash that are ideal. I have inverters, I have parts of the cooling systems, I've got transmission pieces, I have old batteries, all kinds of pieces that you would be hard pressed to get any other way, and yet they are going to throw them in the trash. And that will really help to supplement the vehicles. It's nice to have that component that's dead before that you can play with before you put your hands on a live car. Service information. If you can get your hands on the factory service information, it's the best. If you can't, I understand many of us don't. Some of the information as it relates to OBD2 you can find out there for free. The aftermarket service information works well. But what I've learned, whether you have ALLDATA, Mitchell, Motologic, IATN, Identifix, Diagnostic Network, something else, have a couple. Because I usually find if I can't find it in ALLDATA, I can find it in Mitchell or etc. Or if those two disagree, I can see what Motologic says, and best 2 out of 3 wins. You'll spend a little bit more, but you'll be glad that you did. So here's day 1 of my hybrid and electric class. After we've gone through the introductions and covered all the stuff required by the college, I just posed this question. I said, what do you expect to get out of this class? And it was really interesting to hear the responses. And the one that struck with me, one of my students, he said, Mr. Ward, he says, how do we work on these cars and not die? I said, I got you covered there. I said, can you imagine the paperwork if I killed one of the students in class? I said, I don't want to do that. I said, trust me, you're going to learn a lot and nobody's going to die. But then I posed a second question. I said, hey, how many of you have ever driven a hybrid? Well, about half of them. And I said, how many of you have ever driven an electric vehicle? None. And I'm really fortunate in my program when I teach this and where I teach it to have a big empty parking lot. And I had the students drive the cars in our fleet before we ever did anything else. And, with a, understanding that they had to be very respectful, or we were all going to be in a problem, and they were 100%. Everybody was very respectful. But it's like, how can you fix something? How can you understand it if you've never driven it? And it put the class, we were off on a great start. So really exciting part of the first day. The second thing that I want to cover as we go forward is the area that you're going to service these vehicles, where you're going to teach on these. I tried to set it up very much like if they were working in the local dealership. Hey, this is the designated area. We're going to do this. We're going to make sure the area is clean. We're going to make sure it's dry. We're going to have all of the appropriate signage out. We're going to have any other local requirements met. I wanted to create that environment of respect. After all, these are a high voltage vehicle. And obviously very early on in the safety portion, we talk about, the orange cabling and, the things that we have to respect on the different components going forward. And, understand that while these are very safe vehicles, we have to be responsible. And fortunately, I've never had anything but positive responses from all of the students. This is one of my favorites. This is off of, if you're not familiar, this is the power distribution module on a Chevrolet Bolt, B-O-L-T. It's right there on the top after you open the hood, and there are lots and lots of orange cables coming out of it as the power goes back to the battery, down to the transmission, over to the AC compressor, etc. And it's a really great opportunity to show them, up close and personal, what's going on with the orange cables. Don't even need to raise the car up in the air. So I got to tell you about this picture. I was in a class with that ACDC put on a couple of years ago, and this was a component that was being passed around. And if you take a real close look at this picture, and by the way, this is, if I remember right, this is a connector going down to the AC compressor. If you look very closely behind the back of the connector, you'll see where the wire has been pierced, as in somebody probed it, not once, but twice. Now, here's the good news. This, as I recall, this vehicle was in the shop for a no start condition. The reason that it's a no start is that we have a high voltage current leak. In other words, that piercing has caused a loss of isolation. The vehicle is smart enough to know that this is a problem. It simply has the high voltage shut off, and the car's not going to start. And obviously, for the poor folks trying to figure out this no start condition, I'm sure there was a challenge, and obviously a very expensive repair. But here's the really cool part about this, and I want you to think about that student that you have that sometimes maybe doesn't do what they were supposed to. This high voltage circuit was probed not once, but twice. Never once did we talk about the dead student. We only talked about the car that wouldn't start. My guess is there's probably a test light or some sort of other electrical probe that doesn't work so well anymore. But the reality is, in this case, the car was smarter than the person who probed this high voltage cable. And that's a really good thing when you talk about that student who might act and then think. We're not going to have to do paperwork on them. And this is very typical of the safety elements that are built into these vehicles. And that's why I'm very comfortable having these in our shop and teaching these concepts to our students. So high voltage gloves. Obviously, this is a must when we start talking about equipment. I would tell you to do exactly what I did when I started my program. I walked across to the electrical department where they teach all the other electricity on campus. And I said, who's in charge of ordering the high voltage gloves? Found that person. And I said, hey, I want to add the automotive program to the order. That way we could order what we need. Every 6 months, we can cycle them through, get them replaced. And we'll always have current gloves, and I won't have to worry about it. All I have to do is just authorize somebody to pay the bill. It worked great, still does. But here's what I found that was more interesting. So as part of day one, we're going to measure hands. So we brought one of the sewing tapes of my wife to the class, and we measured everybody's hand and explained to them how that measurement translated into glove size. And one of my students, he looks at me and goes, glove size, Mr. Ward? He said, no, it's small, medium, large, extra large. That's all the Walmart has. There wasn't a single student in that class who knew that there were glove sizes beyond small, medium, large, extra large. And you should have seen the smiles on their students' faces when they now knew what their glove size was. Kind of a weird moment, but again, another one of those things that made the class go extremely well. Obviously, in your local area, find out what else is required. Obviously, we all have eye protection that's required, but there are some areas where you may be required to stand on an insulated rubber mat, or have insulated shoes, or have cotton clothing before your insurance company allows you to work on these vehicles. You know, the obvious stuff, no rings, no jewelry, that kind of stuff. But do a little research before you start that first class. Find out what's required in your local area. Here's something else I'm a huge fan of. This is a lockbox, and you'll notice it has 2 locks on it. So there's a lot of things that can happen to a hybrid or an electric vehicle if you're working on it and somebody decides to, you know, put the key in the car, push the on button, or, you know, in a little bit older car, push or turn the key. So what happens is when we bring that car into the bay, we've got the car set on the lift or however we're going to handle it. We no longer need the key. It goes into the lockbox. Okay. As the instructor, I have keys to one of the locks. The students who are working on the car have the keys to the other. Now it requires all of our agreement before they come back out of the box. And these are really inexpensive. All right. Here's the other tip. Because a lot of people like to leave keys in their cars today. After you've put that key in that box, it's no longer in the car. If that car has a push button, I want you to get back in the car, close the door, push your foot on the brake, push the start button and see if the car starts. And if it does, then go hunting in the center console or wherever they hide that other key and make sure you get it out of the car before you start your work. If you don't, you can have a really expensive mistake. We happen to have a Toyota, I think it was a Prius, if memory serves me right. I could be wrong. That we were servicing the brakes, as in clean and lubricate because of winter here in Chicago. And someone decided, oh, I'm going to check the lights and turn the key on. Bottom line is it cycled the hydraulics on the brakes. It popped pistons out that were hanging from the calipers, and it became a very expensive repair. Can't happen if the keys are in the lockbox. Obviously, when you pick up a car, when your students pick up a car, you got to be careful about where the wires are running. Obviously, the last thing we want to do is damage one of these high voltage cables with a lift and have to pay for the replacement. But hey, that's part of the process. Look up the procedure and know how to properly lift the vehicle, right? Special tools. And I'll just tell you this, they're not as expensive as you might think. The basics are the same as any other vehicle. And there's some variances based on the vehicles that you're going to use for class. As you can see with the Prius that's in the bay here, we're getting ready to change the battery in it for a customer. I've got orange cones out marking the service bay, and there's another orange cone on the roof with a homemade sign that says high voltage. Just something that creates an awareness where people walk around the bay instead of through it, and then I don't have to worry about something happening in an unexpected way. So as you think about meters, obviously any meter that you buy today, regardless of whether you're going to work on hybrid or electric, you should be spending the money to make sure it's Cat 3. Yeah, any multimeter, and that means the leads too. But in this case, this is also an insulation tester where I can make those measurements as well. So it's a combination unit. There's a couple of different models out there. This happens to be my favorite, and I'm going to tell you right now, it's not inexpensive. If memory serves me right, in the case with all the different leads, this meter was $600 or $700, and I only let it out of the cabinet when we're working on hybrid and electric vehicles. I protect it pretty closely, but I have a lot of confidence in this meter. We test it every time before we use it, and I think it was well worth the investment. Depending on what you decide to do with your class, I think a milliohm meter is a really good investment. Again, typically you're talking about an investment less than $500. But if you're going to measure, say, windings on an electric motor, you've got to have a milliohm meter. Your multimeter is not accurate enough. If memory serves me right, this is when we were hooked up to the Nissan Leaf, and one of the windings here was 12.3 milliohms. And I think the difference from one set of leads to the second to the third for the three phases of the motor, there was less than 1 milliohm difference between the three. I mean, so it was ideal. You won't get that kind of measurement with a typical multimeter. This has to be plugged in. The components in the meter have to be warmed to a specific temperature, but it's a really good demonstration of just how poorly a standard ohm meter and a multimeter works. And if you decide to go forward this, I'll share with you a really cool demonstration you can do with just standard wire to prove this out. Insulated tools. Could you get by without them? I think so. What I've done is I've taken a look at my fleet and I've said, okay, where are the areas where I might potentially need to work on a circuit that would require this? And so I have in my special toolbox an insulated ratchet extension, about 4 or 5 sockets, a flat and a Phillips screwdriver, and I think 2 pair of pliers. That's it. A standard plier and a needle nose plier. Because I figured out I don't need anything else. After that, I can properly depower the system and just use regular hand tools. So my investment in insulated tools was less than $200. And I tell you this because if you talk to the tool guy, he's got this $6,000 set that you'll never use. So I don't think you need to make that kind of investment to be able to satisfy your students' needs and to make sure everybody's safe. If nothing else, we probably spend more time just doing the show and tell on them so they can see the difference. So once we've gotten through all the safety stuff, we've introduced them to it, and we're ready to go forward, one of the things that I like to talk about with my students right away is hybrid and electric vehicle maintenance. This is easily one of the most overlooked areas, one of the areas a lot of shops won't even do, yet it's in most cases not much more difficult than any other car, and it really does make a difference on how long that car is going to last, how well the components are going to wear. So, you know, here's the scenario at our customer service desk. My hybrid vehicle doesn't seem to get the same fuel economy as when it was new. So invariably, when you talk to a customer, they've been out on the internet, they've done their search, and they've convinced that, well, that $4,000 battery must be going bad. The reality is they probably just need to perform some regular maintenance. It's pretty interesting. And you know what? It's probably the same customer was going to tell me the same thing about his other car in the garage that's not a hybrid or electric vehicle. So things to look at that, you know, are not high voltage. You know, what tires are on the car? What wheels are on the car? Is there spoilers that have been added? Are there assist steps that have been added? Are the underbody trays there, or were they all knocked off by the parking curbs? Because turns out when they went to buy tires, they decided to get some of those just off the shelf tires instead of the type that were on the car, because it's saving $20 a tire. All this stuff can have an effect. Oil change intervals are longer. But here's the deal. Are we using the correct oil? Right? You know, typically when you start talking about a hybrid engine, we're talking about synthetic oil, 0W20 or 0W something, and it's expensive. Are they using the correct filter? Is the oil level correct? And I got to tell you a story there that I learned early on. The great lesson for the student between quarts and liters is they overfill the Prius. If you want to see an interesting demonstration, overfill the crankcase on a Toyota Prius. So what will happen is when you go to try to start that vehicle, the electric motor in the transmission, MG1, that has to turn the engine over to start because of the extra oil cannot achieve the desired speed because of the resistance of the extra oil. It's smart enough to know there's a problem. The vehicle does not start. The first time this happened to me, I was panicked. First time we had this customer's Prius in the shop, it was fairly new and it's great. We're changing the oil and now we've created a no start. And after finishing my panic session and going backwards as to what we've just done, I looked at the dipstick. And lo and behold, when we got the oil level correct, it started right up and we were fine. Other parts of this, make sure you're using a quality oil filter. The Honda, for example, wants you to fill the filter before you put it on so that you don't potentially set a fault code. Something else, if you're dealing with the Chevrolet Volt, remember that in some cases a maintenance mode warning light will come on if the to run the engine if it's not run frequently enough. In other words, if the vehicle is driven a short distance and runs strictly in electric mode. So here's a challenge for you. Here's a great activity for you with your hybrid fleet, because this is so different from brand to brand. Have your students tell you and then demonstrate for you how to put the vehicle in a mode that the engine will not shut off once the battery gets charged, so that you can perform whatever the procedure happens to be that you need to do. There's a lot of variances, and people will go, oh, hey, I can't do this, I can't do this. Yeah, read the procedure. You'd be surprised how quickly you find out that they're different. Engine maintenance. And I'll pick on Honda for a second, because we still have to make sure we adjust valves. In some cases, the Honda Insight, for example, even has you index the spark plug. I'm gonna tell you right now, I haven't indexed spark plugs on any other car since I worked on Renaults. And I'm beginning to date myself here, but it's important. The other thing that you're gonna find is important is throttle body services. With these Atkinson cycle engines, a clean throttle body is all the difference in the performance. Again, these are items that you typically would never think about on any other vehicle, and I promise you the customer's not thinking about it either. Take a look at your fuel requirements. You think they're all the same until you start down the list and you realize we've got some 87 octanes, but we've also got some 91 octanes here. All right. So one of the questions you may have to ask your customer is, what kind of fuel are you using? Some of the aftermarket is out there recommending these hybrid service kits. I'm not selling anything on the aftermarket side, but I'm gonna tell you there's some pretty good ones out there. And you know, for these vehicles that have a lot of off time when in the electric mode, and even for the gasoline side, this can make all the difference in how long your engine lasts and how clean your fuel system stays. Here's another great activity. This happens to be off of a Prius. This happens to be the warning center, the message center, I guess you might say. Go through and have your students tell you what this all means. And you'll be surprised the responses you get. I'm like, okay, now go get the service information or go get the owner's manual and find out what it really does mean. You can teach yourself a lot just from this information right here. I can tell you right now on this Prius, if that ready light's not on, that vehicle's not going anywhere. That's a dead giveaway. All right, so before I jump over to low voltage controls, we're about what, 40 minutes into an hour and a half. Bill, do we have any questions at this point?
Curt, we do have a couple questions. So here's the first one. The first one goes back to your case study. So the question is, case study number 1, could you have used a DLC, BOB, and power up pin 16 from there?
Maybe, yeah, because you could have plugged in sure, put the power in there and then still be able to hook up your scan tool and see that it works. Yeah, that would have worked just fine. Yeah, that would work well.
Okay.
In fact, I wish I'd thought about that now.
Well, it's not surprising that came from Craig Van Battenberg. So with all his experience, I'm sure he's probably figured out there's more than one way to, do some of this stuff, right?
Yeah, absolutely.
Here's
I
a
know Craig
next.
well enough to know he wouldn't have asked the question. He hasn't already tried it himself.
Yeah, probably, right?
Thank you, Craig.
Next question. Pierced cable was Ford Escape high voltage battery to DC-DC converter.
That must be from Craig as well.
It is.
Okay. All right. Well, he was passing it around, so obviously his memory is better than mine.
Okay. And then here's a question, just came in this now. I've been trying for years to get a hybrid donated. Can JJC donate one of their old vehicles tonight?
Hey, I'm going to tell you what. I get it, and I used to be a service manager, so I don't have a problem asking you for your mother's last dollar right after you put her in the grave. I mean, that's how I made money. Get out there and talk to everybody you know, and don't be shy. I was fortunate, I worked in the manufacturer side for a long time. The Leaf as an example, I knew that was sitting in the Nissan training center in my area and wasn't being used. They'd gone on to the next generation. There was enough differences. They had a newer one. That's a pre-production vehicle. It can never be sold. I went and found the training center manager, and I said, look, this is what I'm doing. This is how I'm going to use it. Who can we call to find out how you can donate that to my program so that vehicle is a benefit as opposed to just sitting here? And he was a great guy. He says, I know who to call. I got him the required paperwork, and we made it happen. You can't tell it from the picture, but the Honda is hit in the rear, and the insurance company was going to give the customer next to nothing for it. And I said, hey, if you donate it to the college, you can. This was a community member. If you donate it to the college, you can take a tax write-off that's worth that much. And they said, we want to help the college, and they donated it. The Prius has got a bazillion miles on it. One of the local parts stores was using it as a parts delivery vehicle and decided to get rid of it rather than put a new battery in it. The Mariner, Granger was building a new warehouse in the area a number of years ago, and they have a great foundation, and they wanted to do something nice for the college. And I said, hey, how about you donate the car and the tools that we need to work on it? And they went, we can do that. And they went out and made it happen. They said, we'll spend this much money, you find the car, and we'll buy it. So it took some legwork. But like these Hondas, they don't have any value at all. You'd be surprised what you can get one for. And like I said before, make friends with the people working on them. In my area, you find out who works on all the taxi cabs, because in the city of Chicago, your taxi cab by rule has to be a hybrid vehicle. So guess what? There's more Priuses on the streets of the city of Chicago than probably anywhere in America. And so you find out who's working on them, and you can find out where all the parts are piled up.
All right. Next question, Curt. Can you share the name brand of the milliohm meter?
I should be able to, and I forget what it is off the top of my head. But if you email me, I know where the box is stored at school, and I'll let you know.
Is your email in the presentation, or do you want to share it now?
It's at the end, yes.
Okay, great. All right. This one's not a question, but it's an interesting comment. It says, not a question, but a 30 caliber ammo can be modified for a key lock box.
Sure, it's a good idea. You probably pick one up at the local surplus store for next to nothing.
Yeah.
Yeah, good idea.
That's what I love about these NACAT sessions we've been doing. It's not just a learning. There's a lot of great sharing, and We're helping everybody. Thanks for sharing that stuff, guys. Well, that's all we've got, Curt.
Okay, then we'll continue, and at the end, we'll do the same. So when we talk about hybrid and electric vehicles, one of the most overlooked topic is low voltage controls. In other words, the things related to the 12-volt battery. You know, the reality is if you don't have a good 12-volt battery, nothing works. Oh, funny, that's what we know about every car, right? And with these hybrid and electric vehicles, in a lot of cases, it's not just out there under the hood, it's hidden someplace. It's behind a panel. And so it gets overlooked. And I can't tell you the number of vehicles that have been towed into the shop, particularly in the winter around here, that are 6, 7, 8 years old, and they don't start, and all we do is put a 12-volt battery in them because it's well past its life. You know, if you're at 10.8 volts, the contactors don't close, the electric motors don't engage, and we're not going anywhere. Now, bear in mind, if that battery is inside the car someplace, it's probably an AGM battery. It requires special charging. That's different testing. And obviously, that's what needs to go back into the vehicle. If it's under the hood, it may be an AGM, it may be a flooded battery, depending on what the manufacturer's decided. And so obviously, if you put a replacement battery in, you got to make sure it's correct. And you're going to find in some cases, you can't just go down to the local auto parts store and just pick this battery up. It's not widely available. You may have to go to the dealer and pay a few dollars more. But you're going to put the right one in, and you're going to be glad you did. This happens to be one of my SnapOn chargers, and it actually has a specific setting for AGM batteries so that we don't blast that thing with 17 volts. We charge it slowly for a long period of time, and we're able to really tell if it's bad or not. You're not going to be able to charge this thing in 15 minutes, but by doing it the right way, you might save the life of a battery that's just low and not bad. If you don't have one, I imagine every program in America does. Get a Medtronics Tester, do your conductance testing. That's the way you're going to test these AGM batteries, and it works well, and there won't be any question. So set the carbon pile aside. That's not what we're going to use. All right, so if we've talked about the low voltage battery, let's talk about the high voltage battery for a second. This happens to be out in, I think this is the one that was in a Prius that we were changing out that was truly bad. If you correctly power the system down, this is a really relatively safe and simple change, something your students can definitely do. To give you an idea, on the left is your typical Prius battery. Individual cells, you can see that they're numbered there. Depending on the vintage of your Prius, older or newer, there'll be slightly fewer cells. Over on the right, just a piece of a Tesla battery. I think this was the one that Craig was hauling around to NACAT conferences for a couple of years ago, or at least part of it. It's really interesting when you look at the Prius battery, which happens to be a nickel metal hydrate, pretty good size cells. When you look at the little individual cells in the Tesla, they look about the size of a AA battery. It's also kind of cool that the Tesla cells each have a kind of a little fuse on the end, so if you lose one, you don't kill the battery. So pretty cool design. Inside the Prius battery, there on the left under the little white plastic covers are your contactors, and just to the right of the back contactor is a current sensor. Those contactors are the heavy duty relays that open and close when we turn the key on and off to allow current from that high voltage battery to flow. On the right is our BCM. No, that's not the battery control module, or I'm sorry, the body control module, but rather the battery control module, and it's internal to the battery. Inside that battery, you have temperature sensors, typically 2 to 4, so that we can monitor the internal temperature of what's going on to control the charging rate. These batteries, whether they're nickel metal hydrate or lithium, are like humans. They like that 65 to 75 degree temperature. On the right, you can see the voltage monitoring blocks that are tied into the Prius battery so that we can monitor the voltage of each group of cells. You can watch that on the scan tool. It's a great diagnostic tool. You can really, on a bad battery, see the variance in the groups of cells and really learn a lot about what goes on in these high voltage batteries when they're not properly maintained. This particular Prius battery, like a lot of the early Prius batteries, clearly has a issue with the corrosion on the connectors, and that's actually something that can be addressed if it's not too far gone and actually save a battery. This is a Nissan first generation Nissan Leaf battery. This is one of the reasons I like the Nissan Leaf that we have. The first generation Leaf battery has a gasket between the cover and the body of the battery, so the cover can be removed. You're real careful not to damage the gasket. You can put it back on. You can do a show and tell on the inside. The newer Leaf batteries actually have a urethane seal and require a cutter that looks like you were taking the windshield out of a car to cut it, and then there's a lot of process to clean that back up, put down a new bead of urethane before you seal it back up. So this one, from an educational standpoint, is a lot more friendly. The nice thing about this battery also is once you eliminate or disconnect your high voltage cables, your low voltage connection, there's no other climate control system that has to be removed. All the heating and cooling in this battery is done through surface contact to the outside, which makes this very student friendly for taking the battery in and out of the vehicle. A lot of the vehicles, as the battery voltage has come down, has used what we call ultra capacitors. You guys are all familiar, and gals are all familiar with capacitors. Obviously, they store electricity. They can be discharged quickly. They have a long service life. They can smooth out voltage spikes, but they can provide power for short bursts. So we can bring that voltage up when we need to provide those electric motors with more power. This happens to be an early Prius inverter, and the 3 cylinders that you see there are capacitors. The newer ones are not external like this. They're farther down in, they're rectangular in shape, and are part of one of the other modules and not separate like this. But I think it's important to understand that when you look at these capacitors, when the vehicle says we're going to turn off the 12 volts, we're going to remove this disconnect, we're going to wait this many minutes before we proceed. The reason that we're waiting X number of minutes, depending on the vehicle and the manufacturer, is we want to make sure these capacitors have fully discharged so that we don't have an unexpected voltage that when we start taking things apart. So high voltage battery cooling. One of the things that will damage a high voltage battery quicker than anything is overheating. And you've got some batteries that are both heated and cooled, some that are air cooled, some that are liquid cooled. A lot of it depends, hey, is the battery under the car? Is it in the car? Air cooled, you have separate blower motors, additional cabin filters. In the case of the Mariner, the air conditioning has to be functional because it has its own evaporator unit in the back that's used to cool the battery. But this is a high voltage battery out of a Camry hybrid. You can see the blower fan is actually mounted right on the top, and it actually blows cabin compartment air through the battery and then out to the outside to cool the battery. And this came out of a Camry where it had a code for a failed battery, and in fact the battery was done. And when we pulled the cover off the battery, lo and behold, this is what we find. In between the battery cells, we are packed with dirt, and what you're looking at is dog hair. Okay? Yes, dog hair. Or at least I hope it's the dog, because if it's a human, they're shedding in the back seat in the worst way. So guess where it came from? By the right rear door on that Camry is the air intake for that fan. So if you have Fluffy who rides there in the back and has you know their head out the window watching the traffic go by, that fan is pulling that loose air right through that grate. There is no filter, pulling it right into that battery, packing that dog hair in nice and tight, and leading to an early death of the battery. So in this case, it was, you need a new battery, but you need to do something about the air intake. Here's the other part. How many times have you seen a customer who has a dog in the back who has some fancy cover and covers it all up and might cover that vent as well? This is a Gen 4 Prius. So this is the most recent Prius. And one of the things you'll notice about the newest version of the Prius is the battery is moved from the back cargo area under the back seat. And right under the would be the under the passenger seat on the right side, there in the rear, right behind where the person's feet would be, there is a air intake for the blower that pushes the air across that battery. And yes, there is a cabin filter, a second cabin filter, and it has a specific service requirement, and it's designed to catch the dog hair and anything else that might have otherwise been pulled in there. The cool part about this is I actually had a customer, this is their car in the shop, we're doing a routine service, and they had actually read the owner's manual and knew, hey, it needed to be serviced, and that's how we discovered it. Most of our customers aren't that smart. Liquid cool batteries. Yeah, we rely on a separate cooling system to cool the battery, perhaps other electronics as well. It may be separate, it may be combined. Many of them have a heater unit so that you can warm the coolant in cold weather. But like any other cooling system, they can be susceptible to leaks. You can use a scan tool to control the bidirectional, the pump so that you can circulate it. There are very specific procedures for pulling the air out of the system so that you don't have air pockets that might cause a problem. The one that I just worked on recently that didn't make the presentation, but it's worth sharing, had a Chevrolet Volt that was complaining about passenger compartment heating, and the Chevrolet Volt uses a electric element when it's in the electric mode to heat, but the Volt uses a conventional cooling system when the engine is running. And interesting enough, when in electric mode we had plenty of heat, but in the engine run mode, very little heat. Well, it turns out that the real problem with this vehicle was that it had a leaky radiator, and somebody went down to the auto parts store and they bought a can of stop leak and put it in, figuring, hey, that's how we fix radiator leaks, right? As opposed to fixing it correctly. Bottom line was there is a line going to the heater core. In that line, it comes off the top hose. There's actually a screen there, and the stop leak did a really good job of plugging up the screen and preventing the coolant flow. So things that you might not otherwise think about, just goes to prove that if you fix it right the first time, you don't have to worry about it. This was the issue I was mentioning on the Prius battery. Here's a little different picture, a little clearer picture. You can see the corrosion there. This battery was beyond saving. But the reality is, if you've ever been into some of those early Priuses around where the spare tire sits, it's very common to see moisture down there. They don't drain very well when debris gets in there. You get the moisture that collects in the area, and this is usually what happens. And Toyota has a fix. They've actually changed the material. If you can get these apart, save all the cells, you can actually clean it up and put the new material in, put the sealant on it, put them back together, and sometimes save one of these batteries. Here's my favorite subject living here in the salt belt. Yes, when it snows around here, it looks like they put margarita mix on our street. The salt is so great. Afterwards, the streets are white. Well, think about your brakes on a hybrid or electric vehicle. They last forever, right? It's because the electric motors do most of the stopping, so there's very little heat generated in the brakes, right? Nothing to dissipate the electricity. And all of a sudden we get corrosion. Calipers become stuck, pads become detached from the backing. And the reality is, if you take a look, this happens to be a C's rear caliper on a Audi Q5 hybrid. You can see the rear pads are barely touching. But you'll see that most of these manufacturers recommend a clean and lubrication of the brake system once a year. So there's an opportunity for you to expand your brake class. But there's some things that you need to be aware of. Obviously, when you put your foot on the brake pad, or the brake pedal, I'm sorry, obviously you're not really touching the brake rotors, you're activating the regenerative braking system. So how would you know if there's any pulsation issues or thickness variations in the rotors? You won't unless you measure them. Here's another one with very little contact. I probably replaced more pads and rotors on these vehicles because the pads have completely delaminated from the backing than I have worn out. I won't spend a lot of time on regenerative braking tonight, but the reality is the electric motors on a normal stop provide pretty much all of the stopping until you get down below 4 to 5 miles an hour, when the friction material will help or bring the vehicle to a stop. So there's very little use of those brakes. With the pedal simulator, there's a variety of different systems out there, but typically you either have pedal travel or pressure sensors that send a signal to the control module, whether it be ABS or hybrid control. And that way we know to obviously exercise the proper amount of braking. The reality is, if we had an event malfunction, we lose our electricity. When you push the pedal down farther enough, you still can make that connection directly to the master cylinder and bring the vehicle to stop. It's not like we're going to have to, crash it into another car or a wall to stop. So there's just an example of the pedal simulator. If memory serves me right, this is what we used on the hybrid Aspen and Durangos at Chrysler. So what's the B position on the shifter? This is why I had them go out and drive the cars in the parking lot, so they can see that maximum regenerative braking and feel how that vehicle slows. Again, great piece of learning for the students. Brake fluid maintenance. Yes, a lot of your hybrid and electric vehicle manufacturers recommend replacing the brake fluid periodically. Before you run out with your bottle of brake fluid and your bleeder tool, remember, typically you're going to need a power bleeder to provide the pressure, because pumping the pedal in a lot of cases doesn't work. And then you're going to need a scan tool. So you're going to want to make sure that you have the proper tools before you decide to service the brake fluid. All right. And if you leave air in the system, you can almost guarantee you're going to have a brake performance problem and probably a diagnostic trouble code. Brake fluid test strips. If you've not used them, they're a little more expensive than coolant, but it's a great way to measure the corrosion level and the moisture level in your brake fluid. Here's just an example of a power bleeder. Nothing fancy, just something that will adapt to the system. The other thing is when you go to work on the brakes, you need to make sure that you can deactivate the system. On our Escape or our Mariner, it's simply a matter of going into the junction block and pulling 2 fuses, and the system is deactivated. Other vehicles require a scan tool or a specific procedure, so that in this case, yep, here's the two fuses, 31 and 24. But you want to make sure you know what that procedure is and that you have all the tools so that you can properly get the system apart and back together and have it operate the way it's supposed to when you're done cleaning and lubricating those contact points so that the pads move freely. Service for the cooling systems, it varies, but I can tell you this, in most cases, you're going to need some sort of vacuum fill system so that you don't get air trapped in the system. A lot of them require you to use a scan tool to run the electric motors. Again, special coolant, typically it's the same coolant in all the systems. And pay attention to your service intervals on that coolant. And then again, just as a matter of reference, your 04 to 08 Prius, as an example, has a heat storage tank and a specific bleed procedure there. Example of an airlift tool. We also do work on diesels, so we already had this, it was critical. Here's your Prius heat storage tank, the thermos bottle that keeps the coolant warm for an extended period of time for the next start. As part of the bleed procedure of this, you actually use the scan tool to run the electric motor that you see just to the left of the thermos bottle there to make sure all the air is out. Just as a note, these are your pressure casts. If memory serves me right, this is the second generation Volt, VOLT, and this is for the battery and for the electronics. You'll notice these are just 5 PSI systems, which is really important if you're going to do your testing, because obviously they don't need the kind of pressure because of the type of heat that's generated by those electronics, as opposed to a higher pressure cap that's needed because of a different type of heat that's generated in a typical engine operation. Electrical 3, you'll see I have a big question mark. And I mentioned earlier, I said, hey, are we teaching enough electrical? And the answer is probably no, because there's topics like AC, magnetism, motors, generators, inverters, and converters that you're probably not even covering. So even if you can't do anything else, you start teaching more electrical and you're on the way. And obviously we can talk about AC here, but the bottom line is, why are we AC instead of DC? AC can power brushless electric motors with greater force. AC can overcome resistance better than DC. That's why the AC is used. This is probably all we ever talk about magnets in our electrical 1 class. But the reality is those electric motors have got a armature that's magnetized, and we make that magnet even stronger when we run electricity through it. So there's a lot more that has to be taught. If you want to understand how an electric motor works, go to the Toyota University and snag on to their explanation. This is just a screenshot with being able to animate it and see all the transistors turn off, see the motor turn, see the waveforms that generated. You're hard pressed to find a better explanation of how it works. We need to talk a little bit about inverters and converters, since obviously, or motor controllers, since obviously this is how we're going to make the vehicle move. And to do that, we've got to talk about power output. So suddenly you've got to talk about watts. What do you mean we got to talk about watts? We talk about horsepower, right? But the reality is we're talking electric motors. So we need to figure out, what's the volts times the amps and come up with our watts. Real quickly, we're going to touch on transmissions. The transmission fluid may be used to cool the electric motor. That may be a unique fluid. There may be unique fluid and filter service requirements. The reality is if you're using the wrong fluid, even just topping it up, you may cause an issue with the insulation on the motor windings that leads to deterioration and potentially a loss of isolation. So be real careful going forward with transmissions if you decide to go that way. Some of them are liquid cooled, where we pass coolant into a heat sink and then pull it through to pull the heat out that way. Here you go. This is, again, if memory serves me right, I think this is a Prius. It's either generation 2 or generation 3. And in fact, there where the coolant passes through, you can see where it's leaking externally. That's not leaking into the transmission fluid, by the way, that's leaking externally. There's actually a gasket that needs to be replaced there. There's an example of a failed stator winding for whatever reason. So let's talk about the HVAC systems. Obviously, if you have an electric compressor, you've got a different oil. In fact, if you have R1234YF, you may yet have a different oil than, say, 134A. Use the wrong oil, you may have a loss of isolation or compressor failure. Make sure that any leak detection die you use is compatible with a hybrid or electric vehicle. A lot of those can't be used. In this case, in the Mopar, they use an ND oil or ND11 oil, which is their POE oil, just as an example. But again, you may have a belt-driven compressor, you may have an electric, you may have a combo unit like you see here. But again, here's another one of my favorites. Customer decides that, hey, their AC isn't blowing cold. Heads down to the local, well, I won't name the auto parts store, but because they all sell this stuff, and buys a couple of cans of the Arctic Freeze and decides to refill the system on their own. And after all, he got the fancy one that has the trigger and the little gauge on the end that you can't see in this picture. And the reality is, you know, it wasn't in the green yet to say it was fully charged, so he kept pumping it in. The system actually worked well for a short period of time and then quit cooling altogether. So when we took a look at the vehicle, when the AC was on, it was very noisy. It sounded like there was, quite honestly, that there were rocks in the compressor. The pressure was equal on both sides when you hooked up the hose. It had codes. The system had codes that would tell you that there was a problem. And the reality is that electric motor had no problem overcoming the high pressures that were created by overcharging the system and destroyed the scroll inside the compressor. So congratulations. In addition to having to get their leak fixed, they had to buy a compressor as well. And a lot more because there was debris throughout the system. Obviously, when we're talking about hybrid and electric vehicles, there's either no gasoline motor or times when it doesn't run, and as a result, we got to have electric power steering. Whether that's rack mounted or column mounted, there's lots of different ones. Here's one off of a Lexus hybrid that is mounted underneath. It could be, this is a Honda where it's mounted on the gear. It might be on the column. GM likes to do that. Be aware that some of these may be higher than 12 volts. In this case, with blue conduit and yellow conduit on the cables, that can be as high as 42 volts. So we want to be careful. 36 to 42 is your typical voltage on those cables. Some of your power steering systems have capacitors internally. So if you disconnect the battery and you're going to service these, again, we have to follow the procedure, wait the prescribed amount of time so that we can discharge those so we don't have a problem. The nice thing about electronic power steering is you have tremendous diagnostics with the scan tool. This happens to be on my Leaf. I can read fault codes. I can look at the level of assist. I can look at motor current. I can look at torque. There's a lot of information that I can take a look at as I do my diagnosis. So it shouldn't be a big deal, but it's a great activity for the students. Remember that most of these vehicles have a steering angle sensor or more. Obviously today now with the vehicles having an increased amount of driver assist systems, we may have to do things beyond a simple alignment when we say replace a steering gear and transfer the parts. So make sure you have the capability of doing that before you take things apart. Hybrid and electric system diagnostics. This is the one thing I'm very confident about. The information that you find is really good. I mean, this happens to be a tech stream. This is the Toyota laptop-based system. It's got 3 codes. If memory serves me right, this was the Camry. Engine failed to start, battery pack deterioration, and a code for replaced battery pack. And you can see here all of the different battery block voltages, all 17 groups that are monitored. And in fact, when you go over here, you can actually see which of the cell groups are out of range voltage-wise. Now, we know before we ever take it apart where we're going to find the low cells. So the diagnostics and the procedures are very good, and I think you will find that working on these is not a really big deal. So very quickly, in summary, hybrid electric vehicles are rapidly becoming a major player in the repair business. Many of these features are becoming standard. Again, some of the most basic vehicles have stop-start. All right, and while it may be just a 12-volt system, guess what? That still is a hybrid, and it's still a great place to learn. And the reality is, the more our students know about this, the more money they're going to make upon completion. And it's not going to just be in our industry. I'm going to tell you who's been snatching up our better students who take this class, and that's the forklift industry. They're screaming for help. Also, folks who do industrial maintenance have scooped up some of the students because they can take what they know about these electric motors and translate that to the production line. So lots and lots of opportunities. So if you're interested, okay, now I want to create a hybrid electric class, or you want some more information for the way I built my class was around the ASE L3 task list. It's when you look on the foundation side, there's not a lot of requirements. So that's where I started. There's my email, Curt@curtward.net, so it's easy to remember. So whoever was wanting to know about the milliometer, send me an email at that address. Or if you want a copy of my syllabus for this class to see how I built it, I'm more than happy to share. I have the blessings of the college to share it, and I'll be happy to send it your way. The other thing that I should mention is my co-author, James Halderman, has information related to the hybrid vehicles and the text that he has written on his website there, jameshalderman.com. We all see that, we use it. He's been one of our good friends to all of our programs all the years, and he's more than happy to share. So there's your task list. There's his website. And he and I are working together currently to try to update the material that he has, to take what I've learned from putting a course together and to put together a new textbook that's going to be electronic. We have to have all of our information to the publisher in, I think it's June of this year. So toward the end of this year or early next year, you should see that text out there. All right, so there's the end of the shameless self-promotion. So anyway, there's my contact information again. So Bill, what questions do we have?
Right now, we've only got one, Curt. So this question is, are there test strips for moisture now? We use an electronic tester, different tester for .3 and .4.
I have only used one set of test strips for both .3 and .4. .3 and .4, obviously the .4 is protected to a higher level, but you could still measure the moisture content. You know, it's going to measure the same. Obviously, that may affect the chart. So that's a good question. I'm going to be honest with you. I've tested a ton of brake fluid, and I've yet to find one that was bad based on the test strips.
And this hasn't been asked, but I'll just add to that. So where do you get the test strips?
I actually ordered mine right through the local auto parts store.
Okay.
We have 3 or 4 parts stores that service our program, and they were able to get them for me. They also, it's the same parts store I use that they get me the coolant test strips for the cooling system work. So that's I let them do all the legwork.
Any other questions, folks?
Well, let me just finish up by saying this. When I first started talking about doing this with our program a number of years, I had a lot of nervousness from my administration who said, "Oh my God, those are high voltage vehicles. You know, are we sure we want to do that?" And I was able to show them that this is that the reality is, you know, these are safer than regular cars. I mean, you hear people who have problems with regular cars and die from it all the time, and you don't have that with these vehicles. It's typically a better class of technician out there working on them, and I found it to be my better groups of students who want to take the class. We've been able to show that this has been a great addition for our students. The college now loves it. In fact, they want to know what we're going to do next. And I think you'll find that if you approach it in the right way, my investment in this is very small. Again, other than my time, I spend a lot of time out there knocking on doors, getting the stuff. But like I said, I'll be more than happy to share what I've learned. And the reality is, just within our NACAT family, we have a lot of good resources if you decide you want to develop a hybrid and electric program. And every one of these people I know very well, I've asked many questions of, and they would be more than happy to chime in and help you make your program a success. So with that,
Curt, I got some questions coming in. It's kind of multiple questions. I think it's going to be easier. I'm just going to unmute. This is Brian Mones, and he's got some questions regarding braking and some parameters. So let me just unmute Brian, and it might be easier to do it that way than to try to go through the different pieces of this.
Sure.
Brian, you're going to need to unmute yourself. Brian, are you there?
You know, if he's not completely familiar.
Oh, he's coming. He's coming.
Okay, I was gonna say it's the top right.
Brian, are you there? You're unmuted, so go ahead. Brian? Maybe not. Well, let me try this.
Okay.
Here's a couple other ones that have come in now. So maybe we can get back to Brian if he can figure out what's going on with his microphone. Okay, so this is from Sean. I'm a high school instructor full-time and an OEM instructor part-time during the summer. I run a one-day hybrid safety class using company vehicle, but that was only because I have the connections. Writing a grant now for a hybrid trainer. Thoughts on a trainer versus live vehicle, I guess is the question.
Okay. I have been down that road already, and part at the request of my college, because they wanted to, if you will, have something that the students could have put their hands on prior to going live on the car. Okay. And so, I was fortunate to have a pretty impressive budget from the college with some Perkins grant money. And so I was able to purchase a Lucas Novell simulator so that it's, I can have a lot of things are done on the training board before we go to the car. There's some others out there. I have only used this one with any real time, but I'm happy with what I have. I mean, I'm not selling training equipment, but there's a lot of companies out there.
This is not a question, but a comment. I'll do it for the humor, right? Years ago when I was with Dodge, the hybrid program was pretty in depth, but the instructor told us if we see one to run. I think there was probably a lot of that going on years ago, right? I think that was kind of what was happening in the industry. So let me go back to. Oh, go ahead, Curt.
Yeah, I'll just tell you, don't run unless you're running towards the vehicle. Embrace this. This is where we're going, folks. And just take advantage of every opportunity you can right now to learn as much as you can. There's lots of opportunities. Get comfortable with it. Yeah, and I'm going to tell you, one of the ways that I get vehicles so that I can play and learn is I become very good friends with with the manager of the local enterprise rental store. It happens to be just literally around the corner from my house. And I tell him, hey, I want something that's hybrid. They have everything in their fleet, and he rotates it over. And I rent it for the weekend. $19.95 a day is all they charge. Drive it, hook up a scan tool, learn, and for $40, I'm a whole lot smarter.
All right, so let me back up to Brian's. I don't think he could get unmuted or the speaker going, so I'll do the best I can with this. So it starts out with a question regarding the regenerative braking. What are the parameters? Question mark. When is regen turned off? Question mark. And then how much battery state of charge, low versus high? So I guess it's a three-part question for you, Curt.
Sure. All good questions, actually. So the regenerative braking is automatic. It's your primary braking on a normal stop, really from any speed. And typically, your regenerative braking will stay engaged exclusively till you're down to about 4 to 5 miles per hour. Really about the same time when the ABS would typically shut off on a lot of cars, and then you're back to regular braking. Now, when you get into some of your electric vehicles, like say a Tesla, for example, you're 100% on that electric. And in fact, if you put it in the right mode, you're one pedal driving. You don't even have to touch the brake pedal. It'll come to a stop and basically hold itself. Most of these vehicles, the high voltage battery is going to run normally somewhere between, it's not going to get, you're typically not going to get any lower than, 30%. And then, it's going to charge, like on a hybrid, it's going to charge back up in that 80% range. So it stays in that window. Obviously, the electric vehicles, it's going to depend on, your next charge. But typically, most of the electric vehicles, you're normally only charging to about 90%. 100% is kind of the exception. And what was the third part?
I think you got it. You got
okay,
all three pieces.
Parts, I think.
Mm-hmm. The last part was battery state of charge, high versus low.
Yeah. So on a hybrid, it varies between about 30 to 85. 30 might be a little bit low, quite honestly. And obviously on the electric vehicles, obviously, it can get down lower than that depending on, how far to the next outlet.
Well, here's a good question. See if you can help with this one. Here in northern Maine, I find corrosion from road salts and extreme temps cause major problems up here. Are the
Oh, yeah.
manufacturers trying to make hybrid vehicles useful for all climates?
Well, I being here in Chicago, I see the exact same thing. And the smart owner, makes that weekly trip to the car wash for the underbody wash to get as much of that off as they can. But the reality is, we've got brake pads and rotors that are lasting, well beyond 100,000 miles, but it's because they're paying for the annual maintenance to clean and lubricate to make sure everything is moving the way it's supposed to. And that's really not a big deal. I mean, we're used to doing maintenance on all the rest of our vehicles. Well, there's not much maintenance to do to some of these vehicles. Well, guess what? On these, you're going to clean and lubricate the brakes. Just different. I think I answered their question.
I think you did, and he came back with car wash question mark. Most years does not get above freezing from December through April. So, yeah, it might be even difficult to find some car washes that would be open in the freezing weather. But I guess you do the best you can.
Ones like we have on my house where it's dry, all dry before it goes back out the other door.
I think it's one of those things that we don't see get talked about with car owners, that cleaning that car is part of their maintenance.
Yep.
And nobody talks about it. So that would be good reminders, to let these people know, hey, these cars need to be washed too. So
that's for sure.
It looks like that's the end of it, Curt. So, man, thanks for a great job. Excellent. And I want to remind everybody before we wrap this up tonight, don't forget we have a instructor roundtable for February 25th. That's going to be a Thursday night, and that's going to be moderated by Rick Martineau and Drew Barnes. So the registration for that will open up here probably about a week or so before the actual event. Watch your emails, watch the social media for NACAT. Make sure you like us on social media, and make sure you're following us on social media. And we look forward to seeing you next month on the 25th. Have a good night, everybody.
Thank you, everyone.